Okay, here I have a problem where I multiply two matrices, and they're fairly large matrices, and I want to use properties to simplify the multiplication. All right? There are many ways to look at a multiplication, so this exercise gives you some examples of how you can look at this multiplication. Now, first of all, when we first introduced multiplication, we said that multiplication of a matrix by a vector, multiplication of matrix by matrix can be considered as multiplication of the matrix by each of the column vectors in turn. So I can write AB as 3 columns, right? Because A is 4 by 3, and B is, not 4 by 3, 4 by 4. A is 4 by 4, and B is 4 by 3. So the result is going to be 4 by 3. So there are 3 columns. And those 3 columns are AB1, where B1 is the first column of B. Second column is going to be AB2. Third column is going to be AB3. Now, notice a pattern in B. Look at this first column, second column, and third column. There's a very close relation between these 3 columns. In fact, notice that B2, if you look up at B2 in this case, by the way, if you haven't paused the video and worked the problem, you should go ahead and do that. Go ahead and pause the video and try to work the problem yourself, and then you can compare my solution. All right, so if we go back here and notice, B2, which is the second column of B, is simply equal to minus 2 times B1. Just look across and you'll see each entry in B2 is minus 2 times the corresponding entry in the column of B1. Okay. Similarly, B3 is simply 4 times B1. So I can write this as AB1, AB2, AB3 is simply, let me just write this down. B2 is minus 2B1, and B3 is equal to 4B1. So that gives me AB is equal to AB1, A times minus 2B1, which is minus 2AB1, and AB3, which is 4B1, so that's 4AB1. All right. So what that means is I only need to calculate AB1, and I can obtain the other 2 columns easily. You can obtain columns 2 and 3 easily from column 1. Okay, so let's focus on column 1 then. Now A was what? A was this here. Let me go ahead and grab it and copy it. I'll just copy them both. If I can make this work. Grab A. Well, I'll just grab A and then I'll write B. Here's A. Copy and paste down below. Okay. Well, it's not letting me go farther. Let's try again. Okay. I'm going to paste it here. Right, there's my A. Now remember B1, I'll just pull off the first column of B1. B1 is going to be, let's just do it from up here. It's going to be 2, 1, 0, minus 1. Okay. So remember, once I find AB1, I can easily find the second column and third column. So let's focus on this. Now let's see if we can see a relation between the rows of A. All right, so here we have this first row. to get the first element of this product, I'm going to have to take this row times this column. So I'll just have to do that. Then I'll have to take this row times this column. Now, take a look at this row. There's a relationship between this row and the first two rows. In fact, this row is the first row minus the second row. So that means that the third entry of AB1 is going to be the first entry minus the second entry. Okay, think about it. If this is a linear combination of the rows, then the matrix multiplication is going to be a linear combination of the matrix multiplication results. Okay, so this third row here, like I said, is the first row minus the second row. So the third entry of the product is going to be the first entry minus the second entry. All right, what about this last row? This last row is just negative of the first row. So the last entry in AB1 is going to be negative of the first entry. So I can express that like this. I can say AB1 is equal to, well, I don't know what this value is, I'll call it X. I don't know what this value is, I'll call it Y. Now the third value, remember, the third value is going to be the first value minus the second value, so that's X minus Y. The last value is the negative of the first value, and that's going to be minus X. Okay. So now all I have to do is compute X and Y. So where X is going to be equal to what? X is equal to the first row times this column. So X is equal to 1, 3, 5, 7 times 2, 1, 0, minus 1. Right? Now what about Y? Y is just equal to the second row times the column. So Y is equal to 1, 1, 1, 1 times 2, 1, 0, minus 1. Okay. All right, so let's just go ahead and do it. At some point we're going to have to bite the bullet and do some calculation. So X is equal to 1 times 2, which is 2, 3 times 1, which is 3, 5 times 0, which is 0, and 7 times minus 1, which is minus 7. So that's going to give me minus 2. All right, how about the Y? Y is just the sum of the elements of the column, so it's 2 plus 1 plus 0 plus negative 1, and that's equal to 2. All right? So in summary, I just fill in all the blanks that I have. So I have AB. Let's start with the first column. I know I have minus 2 and 2. All right, then the third entry of the first column, I wrote up here, is just X minus Y. So that's minus 2, which is minus 4. And the last entry is minus X. X was minus 2, so I get 2. So that's the first column. Now what about the second column? Well, I've got that answer up here already. The answer up here already says the second column is minus 2 times the first column. All right? So minus 2 times the first column is going to give me 4 minus 4. Minus 2 times minus 4 is 8. Minus 2 times 2 is minus 4. Okay? And then the last column was 4 times the first column. So I just need to take the first column times 4. So that's going to give me 4 times minus 2, minus 8. 4 times 2, 8. 4 times minus 4, minus 16. 4 times 2, 8. And that's the final answer for AB. So I don't know if you can say that's a lot simpler than multiplying out the matrix. But I gave a lot of details that I wouldn't have if I was just doing it on my own. So really, I think this does in the end save time. Okay.